What's up, guys? Let's talk about the most common communication protocol, HTTP. So let's get into it. So, Hypertext Transfer Protocol, or HTTP, try saying HTTP 5 times fast. It's actually kind of hard. Um, so let's introduce this. So Hypertext Transfer Protocol (HTTP) is a stateless application layer protocol for distributed and hypermedia information systems. It's the foundation of data communication for the World Wide Web. It's considered the de facto standard for client server resource sharing. Web servers and client applications or browsers must adhere to the message formats and transmission methods provided in the HTTP specifications. When we type a URL into a browser, the web server receives an HTTP request directing it to fetch and deliver the specified web page. HTTP is based on concepts of request and response. So one program, the client, requests another program, the server, and the server returns a response. The client usually makes requests in the form of HTTP commands, and the server responds with data in the form of documents. These commands are structured by different API architecture styles that we'll discuss later. We'll discuss the essentials of HTTP, its request and response formats, HTTP methods, response status codes, different HTTP headers. We'll discuss the significance of HTTP in APIs, and we'll discuss the secure version of HTTP, which is HTTPS, right? So let's talk about the HTTP message flow. So HTTP communication is initiated by the clients sending a request to a server, and the server will then respond. And we'll discuss the request and response message structures for this protocol. So let's talk about the request structure first. An HTTP request message is composed of the following four components, which we'll get into. Firstly, the method, right? So the method, HTTP provides built-in methods that determine what kind of action a client wants to request/perform. So as we can see in this request structure, in line 1, we have the method. And secondly, the request target and version. So the URL or URI, which is a unique address or identifier that determines a resource's location, right? So for example, we have Wikipedia right here. Here's our domain name. Here's our protocol. And then here we have our resource path, right? So this is how we tell the server what resource we're looking for. So this uniquely identifies a Wikipedia page named University of Illinois Urbana-Champaign, right? And it also shows which version of HTTP is being used. So if it's HTTP 1.1 or HTTP 2.0. So all in line 1, we have the URL, the method, and the version of HTTP that we're using, right? And then we have headers, right? So this allows clients to pass additional information between the communicating entities. There are always a series of key value pairs containing important information about each request. Request headers mainly contain the following information: server information from where data is requested, information about the browser being used, the kind of data formats a client can accept. So here we have, the different lines. We have all the different headers and key value pairs. So next we have the body. So the body is used to communicate any application data and client wants to communicate to the server. The format of data should be mentioned in the header so that the server clearly understands the data. So we'll get into this, but there'll be like JSON, XML. There'll be different formats that will be specified by these headers, and the body will then be in that format, right? And this will be like the additional information that we send to the server so it knows, um, what exactly you're looking for, on top of the URL, or, if you're going to do another type of method, it tells the server additional information that you want it to know, right? And so a sample HTTP request is shown representing all four parts of an HTTP request, right? So here we have our method, right? And we also have our target and HTTP version right here. Here we have all of our headers, key value pairs. So you have our key right here, and then you have a colon, and then you have our values. And then here's our body in this looks to be JSON. So let's talk about the response structure of an HTTP request, or the response, what that looks like in HTTP. So it has the same format as a request with the following modifications. The method in the request is actually replaced with the HTTP version, and the URL in the request is replaced with a status code, right? So here we have our version. Instead of our method, we have a version, and then we have our status code instead of the URL, and then we have a phrase, right? All in line one. And so our status code will tell us, it'll give us a broad idea of, what the response is, what the, whether it was, there was an error or whether everything was okay, right? And then there'll be a phrase associated with that status code, which we'll get into. And so let's talk about the status code and phrase, right? So it's a 3-digit number that conveys what happened with the client's request on the server side. The phrase part is a group of words that convey some meaning along with the status code. So some of the phrases are okay, moved permanently, unauthorized. There's a funny one called I'm a teapot. I don't know why that exists, but if you know APIs already, you probably have heard of it. Status codes are divided into the following 5 different categories. So from 100 to 199, they're all just informational status codes. 200s are usually that everything was good, the request was accepted. 300s are redirections. 400s are clients on the client side, or errors on the client side. I don't know what I said there. 500s are errors on the server side. So good to know these. So headers. The headers in the response provide extra information about the server and the response itself, right? So, yeah. I guess it just tells you about the server, the response. I'm trying to look at this example here. So I guess in this example, it says that the connection was closed, the date, how long the content is, what type of content it's returning. It seems to be a JSON, and when it was last modified. So I think that'll tell us how old this data is. So this is good information if you're the client and you want to know more information about your response. And then you have your body, which is the response body consisting of the data from the server that the client has requested. So headers allow the exchange of extended control information between the client and server. Large number of headers available in the HTTP specification and they're extensively used. So there are a lot of different headers that can be used here. And in HTTP, why are the control or headers and application data included in the same request response message? Well, one thing about HTTP is that it's a stateless protocol, right? The server should not keep any data relevant to a request. This approach diminishes the statelessness behavior of HTTP. It's also too much data and information for a server to hold on a client, right? And also, like coupling everything together in just one message. This avoids sending too many requests. So if you were just setting the headers by themselves and then the body by themselves, like this would be too many messages to deal with, like in terms of traffic, right? And this allows it to stay stateless and keep the network more free. So let's talk about the different HTTP methods, right? So HTTP protocol is packed with several methods that are used by clients to request an action from the server. So there is the GET method, right? This is like a pretty common one, the first method of HTTP, and it's used to read data from a web source. For example, reading a page from the server. So we have some curl commands here. If you open up your terminal, if you have like Linux or something, you can curl and get, from a certain domain. So I'm sure maybe you've tried this with like Google. You can go and you can download the HTML for Google. And then we have our post method, which sends user-generated data to the server in order to create or update a data source, right? So here we have our user, password, post, right? We have our put method. This method creates a new source or updates the existing one. So it should be used to replace whatever is present on the target URL, right? So here it should be updating our name, user, our username and email, right? For, our login information for this user, right? And then we have our delete method. This method deletes a resource from the server. For example, if we wanted to delete a user having a specified ID or name, so we should be able to delete, user ID 1, right? And then we have our trace method. This method echoes the contents of an incoming HTTP request. So this is used mostly for debugging purposes. And we have our connect method. This method makes a two-way connection with a web server. It can be used to access a website using SSL to, open a tunnel. When a client wants to tunnel a TCP connection with a specific server, here's an example. We have our options method. This method queries the options for a page supported by a web server. So we use the options method if we want to see what HTTP methods a domain can support. And we have our head method. This method asks for information about the document. It's faster than the other methods because it's significantly less amount of information is being transferred there. And HTTP also supports custom methods, which extend its functionality, so it's not just the methods mentioned. And so let's talk about the HTTP headers. So hopefully this is large enough for you, this table, but we'll talk about the different headers. The request to a server may contain additional lines specifying extra information, which are called request headers. Authorization is a request header that represents a list of a client's credentials. That's one example. A response can also contain headers from the server side. Server is a header that shows information about the server in a response, or the server in response. Some headers are applicable to both request and response. So the header content type can be part of both the request and response. So the client can send a content type of application JSON, and you can get a response of content type application XML, right? So they're in both request and response. Following are some HTTP headers that can be used in requests, responses, or both. So here we have a header called accept, right? And that's for the request and the type of pages the client can handle. If modified since is in the request. So the time the resource was first downloaded from the server, if it can be used to ask the server for a specific resource, has changed since the client got it. We have authorization, which we spoke about. Content encoding, content length. There's a long list of these, so you can do some research on your own. And let's talk about the significance of HTTP in APIs. So the communication ecosystem was already present in the form of HTTP, right? And APIs simply use that ecosystem to their advantage instead of, trying to reinvent the wheel, right? The adaptation of HTTP by APIs brings the following advantages. HTTP, it's well known to many developers, simple to use, upgrade, and scale. It allows for cross-platform and cross-language communication. It provides a uniform interface for communication between entities in the form of request and response messages. It's a fast protocol because it requires minimal processing. And due to its adaptability, APIs based on it can achieve a wide range of goals. So you can make custom requests based on the use case and utilizing different built-in methods provided by HTTP, right? So repeat requests can be handled more quickly because responses can be cached. So that's another advantage. And HTTP supports various types of encoding techniques that make an API efficient, right? So let's summarize this. What did we learn in this video? We introduced a widely used client-server communication protocol known as HTTP. We described how an HTTP request and response are structured. We learned about the commonly used HTTP methods. We expanded on the different HTTP requests and response headers, and we discussed the importance of HTTP in API design. So let's do a quick quiz. Which parts of the request and response messages are encrypted while using HTTPS? So HTTPS is the secure version of HTTP, right? It's on TLS. And yeah, right. So HTTPS is HTTP over the secure socket layer, SSL, right? The entire HTTP request and response are encrypted. The headers and the body are also encrypted, right? So the whole thing is encrypted, and it's much safer, much more secure. And that's why you're always going to see HTTPS in, whenever you go to a website. If you look at the protocol, it'll be HTTPS usually. So hopefully you learned something. Leave a like, comment, subscribe. Let me know if anything. Thanks for watching.